Any sufficiently advanced technology is indistinguishable from magic.
I'm going to ask you back to that Hawking book, because I've not seen it. Hawking, very clever title. I've always wondered, is he really a world-class, one of the top ever physicists, theoretical physicists, whatever? Or does his condition and his heroic continuation of his work in life, despite these incredible conditions against him, kind of elevate him into almost a godlike status? I used to see him every couple of years. He'd come to Caltech and give a public talk. It was quite a show when he would show up at Caltech. It'd be like, well, Stephen is speaking next Wednesday night at 7. All right, well, like at 2 in the afternoon, there's people lined up, out in the lawn playing Frisbee and waiting, for their free spot in the 1,100 seat auditorium. It's like, wow. And then, he rolls down the aisle with his helpers in his chair, standing ovation just for showing up, before he even speaks. And, people are just hanging on every sentence. And of course I get it because, his condition, his heroism and so on. But I always wondered, is he, way up there in the pantheon of the greatest of all time, Newton, Einstein, Feynman, Hawking, or not? I just really have no way to judge that.
No, and that's a big thesis of this book. It sounds like you'd really enjoy it. But the book actually goes through as a physics. It goes in reverse from starting with the movie about his life and maybe his final papers, all the way back to his 1965 thesis with Dennis Sciama at Cambridge, at Oxford. I think he was at Oxford, and then he was teaching at Cambridge. But no, it makes the case. And actually, Michael, as you're right, he would come to America. He didn't get there on British Airways. I mean, he got there on a private jet, and oftentimes the private jet was so even not inadequate. He had to take an ambulance jet from Cambridge to Caltech. That's not inexpensive. So he had all these backers. There's a guy who backed him who had established a Stephen Hawking chair at Texas A&M, and he would have him come out. And then once he was working on his final papers with like Andy Strominger and others, and every time he'd get approval from his doctor to come out on the ambulance private jet, which is much more expensive than a regular private jet, because there's only like one or two in the world that could actually do it. And so Andy Strominger talks about how they had to get him out, and the doctor said no. He had gotten really sick. He had just had a flu, I think. And this is like 2017, about a year before he died. And the doctor said no, he's too ill to travel. And then in the book, it says that his colleagues wrote to his doctor and said, if you don't let him come, it may cost a Nobel Prize. And I thought it was perfect for my book. Losing a Nobel Prize is all about how scientists worship the Nobel Prize as a kind of gilded graven image that literally has Alfred Nobel's picture on it. And we have as much of a religious proclivity as any secular, humanist does, except we think it's all great because it's just wrapped up on this fun thing called the Nobel Prize. But it was funny to me that his doctor only let him go at great risk to his own personal health and maybe even the guy's medical license because of the potential to win a Nobel Prize, when actually there was no chance of him winning a Nobel Prize. He did a lot of good work. What kind of hampered him, as this guy talked about? So for a while, I was kind of frustrated by Hawking because I heard him speak several times. I heard him speak only once in my life, and that was in the 90s in London at a Royal Academy meeting. And he gave a public lecture. And at the end, someone said, "Why did you write A Brief History of Time? It's rumored that no one's ever gotten all the way through it, not even you, and nobody understands it." And in his computerized voice, I remember this distinctly, Michael, he said, "Because I had to pay for my daughter's college." And everybody laughed. It's kind of a cute line. But only now do I realize how much he had to go through. And Leonard Mlodinow's book that you had, The Biography of Friendship, I had Leonard on my show. And I realized he had to form kind of Stephen Hawking Incorporated, as I call it, or Hawking, as Seif calls it, because he had to be turned over. Imagine being turned over every hour when you're sleeping to drain your tracheostomy and have fluid, and you couldn't do anything. You never had privacy. Your spouse was like your mother or your parent, wiping you. It's disgusting. Yeah. I can't imagine how much respect I have for him on one hand, but it's impossible not to think that didn't play into this. He I interviewed Neil deGrasse Tyson the other day, and he said even during COVID, I couldn't go down the street with a mask on and not get recognized. And that's like one of Neil deGrasse Tyson's, biggest kind of frustrations, just like he has no privacy anymore. Well, Stephen Hawking said, I can't like put cloaking devices on my wheelchair. Like everyone's going to know who he was. Everyone always wanted his time. And so I don't begrudge him for doing a lot of things for financial reasons, because he had to take care of it. Just like Galileo, he had ex-wives and children, from different people to support. And there was this constant need and terror. Who else was going to provide for him? One
of the theses of this book is that he's not in the pantheon of the great physicists.
No, definitely not. No, he's as I said, the two biggest things that he claims are his reasons to not believe in God: the Hawking-Hartle theorem and the M theory that he didn't contribute to but popularized. Those are not accepted by the lion's share of practicing physicists. The work he did on singularities is very important, but then again, he kind of disavowed that to work on the no boundary theorem, which kind of obviates the need for a singularity. And then the black hole Hawking radiation is incredibly interesting, fascinating mathematical work that suggests that black holes may emit light with an equivalent temperature of 1/trillionth the temperature of the sun that will never be observed. So for those reasons, you might make an argument that Penrose did this great work on black holes with Stephen, and so since Penrose won the Nobel Prize, maybe Hawking would have, but Penrose made a numerous amount of contributions far beyond just the black holes for which he was recognized. Hawking was much more narrowly focused, and I think it's impossible to imagine how much he did, with so little physical ability starting in the early 1980s. But certainly it was his esteem amongst the general public is far eclipsing of his contributions to most practicing. Like the amount of citations that he has to papers that he's done are very limited in the practicing work of physicists today.
Interesting. Let me ask this next question by prefacing it with a quote from Darwin. When The Origin of Species came out, of course, there was some hullabaloo about its implications for theism and the need for a designer to explain life and so on. And so in the second edition, he addressed this question: is the theory of evolution by means of natural selection a threat to belief in God? And recall that Darwin's wife, Emma, was deeply religious, and he consciously avoided being too militant about his eventual agnosticism. He never called himself an atheist. But here's what he wrote about his own theory. I see no good reason why the views given in this volume should shock the religious feeling of anyone. It is satisfactory, as showing how transient such impressions are, to remember that the greatest discovery ever made by man, namely the law of attraction of gravity, was also attacked by Leibniz as, quote, subversive of natural and inferentially of revealed religion, close quote, from Leibniz. Darwin continues, a celebrated author and divine has written to me that he has gradually learned to see that it is just as noble a conception of the deity to believe that he created a few original forms capable of self-development into other needful forms as to believe he required a fresh act of creation to supply the voids caused by the actions of his laws. So my question is it possible that there is a mind, a conscious being, a God, an intelligent designer behind it all, and the way he created the universe, stars, planets, life, complex organisms, all the way up to us and sentience, is these laws of nature that scientists are discovering. That's how he did it. He did it through these particular laws: gravity, natural selection, and so on. And therefore, you're kind of taking out of the equation this sort of personal God. Well, you can still believe in that, but separately from that, this is how he did it. So in a way, back to the old natural theology arguments of the 18th and 19th century, studying nature is a way of getting at understanding God's mind, because those are the laws we're discovering. That's how God does it.
Yeah, I think that's a fantastic point, and one not too dissimilar to the point I tried to raise to Meyer, which is this this notion of kind of lethargy or slothishness of the deity. So assume the deity existed. He instantiated the laws of the universe. He even programmed in that, carbon could form in the heart of certain types of stars from a triple alpha nucleus collision that lasts for a trillionth of a second under these exact chemicals, and that would create carbon, and then phosphorus would come later, and then GCTA would, they'd all precipitate out in different forms, and it would all part of this God's plan. Still, it would have to be that the deity instantiates that at very early times. Because there's no sensor, there's no interaction, there's no on a continual basis. I don't think people believe that God is in there separating RNA and matching up pairs of DNA strands, et cetera, et cetera.
Right,
so
right.
It is kind of the clockwork. What's that?
Yeah, right.
So therefore, the God that Stephen believes in, I said to him, the inescapable conclusion is a Deist God. It's not a personal God. Mm-hmm. In other words, it is a God that established the laws that you and I would evolve. And so God created those. Let's just say I stipulate that. I believe there was an intelligent, let's say I do. He would have had to do so at an extremely early time, billions of years before Homo sapiens would exist. And then the form of Jesus Christ would come 2,000 years ago. So if that is true, then God established the laws of nature that by which we are to grasp his interactions with humanity extremely long ago. So how is that different than the deistic God, the unmoved mover, or the first cause God? Mm-hmm. To me, it doesn't display any difference functionally. But so then yes. So I think it's a very different thing. And I asked him, can you get ought from is, but can you get, Jesus or whatever, or God of Moses and Abraham? Can you get that from is? In other words, the fact that the universe obeys laws of physics, the laws of biology and biochemistry, and eventually sociology and political science and everything. Can you get those laws? Can you get a personal God from those laws? I don't personally see how you can, but that doesn't prevent me from looking. See, here's the thing I have trouble with agnosticism, even myself. I don't believe that there's such thing as like a super happy militant atheist. Like just because you express your opinion really forcefully doesn't make it any more so than my opinion as a happy Buddhist, or whatever, right? It's just like, okay, that's just your form of expression. You yelling at me, the God doesn't exist doesn't help convince me any more than a quiet, reasoned argument would have us. So, I like to think about, where would God display his existence if he would? And then what would that consequence? So we all talk about that we'd settle for what Woody Allen called the divine sneeze. Like, that's all I want, a divine sneeze. And I hear that a lot from my atheist friends. They'll say, actually, I was reading a book recently by Avi Loeb, who and you had on the show, right? Mm-hmm. You had Avi on, right? Yeah. So He said, oh, well, if God really didn't want Abraham to sacrifice Isaac, he wrote this in the pages of that trash pile of a magazine called Scientific American. Now, I'm just mad that you're not writing for them anymore. But anyway, he wrote this in Scientific American. I love Avi, but he said, all God needed to do is give him like a modern day iPhone, and he could have recorded it. And I said, Avi, come on, you're a Jew, you're an Israeli, you're Jewish like me. Did you not forget the story of the golden calf? He's like, no, of course I know that. Every Israeli, no matter how secular they are, Michael, knows the Bible, the Old Testament, better than any Sunday school preacher of highest intensity that you'll ever meet, because they get it in their public schools. They learn the Torah. But anyway, I said 40 days. Imagine this, 40 days after witnessing 10 supernatural plagues devastate Egypt, the most powerful superpower country ever existed in human history at that point, and then split the sea, another miracle, and do all the 40 days after that, they melt down some gold and make an idol. And these are supposed to be Jews. I said, Avi, we're supposed to be kind of smart. Like 30% of Nobel Prize winners in physics at one point were Jewish people. We make up I'm not a Jewish egotist. I mean, all you have to do is get in front of one of my fellow tribal members at a certain event, and you'll realize that they're just human beings like everybody else. But I said, Avi, do you think human nature has changed? In other words, if tomorrow, Stephen Meyer's book gets a blurb from God, and it says this book is and this is my favorite book of all time.
This is how I did it.
A day later, yeah. Right. Do you think a day later? Well, that's like O.J. Simpson's book, right?
Yeah.
If I did it. But do you think a day later anyone would still believe it, or a week later? No, we'd come up with different explanations. I remember hearing in the Soviet Union in the 1980s, it was very, very anti-religious, and there was, there were people and that would work for the, in the physics departments, et cetera, who would say things like, the splitting of the Red Sea was just caused by a huge windstorm, and there was a gravitational pull because there was an eclipse back then. And I actually had Richard Friedman, who's a dear friend of mine. He writes about
I know him.
But is that any better? Is that any better or worse than a miracle? I mean, so to me, it's kind of
well, in a way that would be a miracle.
Yeah,
I mean, that would be how God would do it. How would God actually perform the miracle of splitting the Red Sea? Well, he would generate up a super storm with strong winds, and he would have an earthquake or whatever. And this is what I'm getting at is this question of, well, how does God do it? How does the mind interact with the stuff? How does it reach into the universe from wherever God is and stir the particles in some way to cause the miracle, or laws of nature or whatever? I had on the podcast two philosophers, James Davison Hunter and Paul Netoliski. They wrote this book called Science and the Good. It's a critique of myself, Sam Harris, Steve Pinker, and Jonathan Haidt, and others that are kind of doing evolutionary ethics. And the entire book is basically a critique saying this is why these guys have not explained the origins of morality, much less how to derive an ought from an is. Okay, so I reviewed the book, and I liked the book, and then I thought I'll just have them on the podcast, so I did. We're going to release that in a couple of weeks, I think. In any case, turns out they're theist philosophers, both of them. I had no idea. So to their credit, they wrote this book without ever once mentioning God or anything like that, or even their positions. So we spent most of the time talking about why evolutionary psychologists and ethicists are wrong. So I said, okay, then how do you think it happened? Where do you think is the origins of morality? And in so many words, it was, God did it. It's like, yeah, I know, but how? I mean, in other words, it's kind of a God of the gaps argument. And even though modern intelligent designers disclaim that, they said, we're not filling in the God of the gaps. Well, you are. You're just saying in so many fancy words, God did it. Well, but how? And then if it turns out, they have some argument, well, he used the storm to cause the sea to split, or he caused the quantum foam fluctuation, and that's how he created the universe. How is that any different from what scientists are trying to do to figure out how it happened?
Right, and that's one of the problems I actually have with people like Neil deGrasse Tyson and Michio Kaku, again, guests on my show. And so I say it with respect. Sean Carroll made this argument to me in person a long time ago, that Isaac Newton knew that there were these gaps in the Principia, in the theory of universal gravitation, rather, and that the only way he could plug them, the instability, because gravitation is the only force that's only attractive. It has no repulsive gravity in the particle-to-particle sense, the way that electronic charges do, et cetera. Nuclear forces can have repulsive forces. And so he plugged that hole by postulating that God or angels kept the particles in place at certain times in their orbit when they're so-called gravitational resonances. And Stephen Meyer, to his credit, did the research. He was at Cambridge, after all, and he looked through the Principia. There's not once does Newton make that argument. And so you have to be careful with the God of the gaps on the other side. I feel like, for the secular community to have more intellectual honesty than the theist community, they have to have higher intellectual standards. Mm-hmm. And to me, to let that slip, and Stevens documented this particular, that's a huge lacuna in their mm-hmm. case, as far as I'm concerned. Because I actually believed that for a very long time, and you can read it in Kaku's book. He talks about it. Also, Kaku talks about the famous questions of Thomas Aquinas, and you know those better than anybody. But one of those is like, anything designed had a designer. And Michio's just kind of glibly, he says, one of those is a good question, where did the universe come from? But then he says, oh, well, like evolution explains the origin of life. And I'm like, actually, have you read Darwin's letter to Huxley? Like where he says it's as much rubbish to think of the origin of life as it is the origin of matter. And it's like, no, the origin of species is what Darwin was talking about, not the origin of life. Those are hugely different things. And Michio just says, oh, no, evolution explains the life. No, there's not a single working experimentalist in the field of origin of life research, which is going on around the world, that has ever been able to replicate even the most simple versions of it. So there's a huge, I'd say, disadvantage to trying to take on the Myers of the world. There's many obstacles, rather. There's one huge obstacle to accepting God, which is just like the implausibility, and the hiddenness of such an entity if he does exist. But the other, I feel like atheists have it really hard, because we don't understand the origin of life. We're not any closer than we were 100 years ago. People talk about the Miller-Urey experiment. That was done in part here. I mean, Urey and Milner were both here in San Diego.
Yeah. Well, Robert Hazen has a nice course at the Teaching Company. I think it's like 24 lectures on the history of the origins of life research. There's actually, a dozen different theories. Back to the consensus problem, there's no consensus. There's not an emptiness or a lack of theories about how it happened, including directed panspermia or just panspermia in general without the direction. But there's no consensus. So, okay, maybe it's a super hard problem. Maybe they're just not asking the question the right way or whatever, But again, we what's the alternative? Well, God just did it. Well, how? Did he use RNA to create DNA? Because if that's how it happened, then we should continue with that research. Or did he use, on some other planet, he used some other self-replicating molecules that weren't either RNA or DNA? Okay, that would be interesting. But what exactly did the deity do or whatever? Anyway, so a more broad question, since you used the word agnostic to describe yourself. This word was coined by Thomas Henry Huxley in 1869, by which he meant not knowable in any kind of empirical or rational sense. There's no experiment you're going to run. There's no set of clever arguments like the Kalam cosmological argument or whatever that everybody's going to go, oh, yeah, that's right. It's just not knowable. So, today most people use the word to mean like, well, I'm agnostic about climate change. Maybe some new data will come in and then I'll make up my mind and decide if I believe or if I'm still skeptical. No. So one position, I'm conflicted about this. I tend to think we're never going to know, right? It's just, we've all hit this epistemological wall. Maybe it's an ontological wall. Maybe we can never know. It may be an unknowable concept. Or maybe I'm wrong. Maybe the kind of universe we have is the kind of universe that would imply there's a God, if you follow Stephen Meyer's arguments, or to follow Victor Stenger's arguments in his book, God, the Failed Hypothesis. He says, no, actually, God is a testable hypothesis, and he failed to test, and here's the 10 reasons why. And so I'm just curious what you think about that. Is this an unknowable concept? Is that what you mean by agnostic? Or do you mean I'm waiting for more evidence to come in or better arguments?
So I kind of got this from Freeman Dyson, who called himself an agnostic, but again, he was functionally indistinguishable from Richard Dawkins. I used to tease him. I regret teasing him, because he's such a sweet man. But anyway, we had a great kind of friendship that I think about and miss him all the time. But one thing he said to me is, he said, Brian, there are two different things in science or in life. He said there are mysteries and there are puzzles. Like a puzzle, my kids can do a Rubik's Cube. I can never do a Rubik's Cube without like taking apart and reassembling it. Actually, I could do it. I joke, if you gave me a Rubik's Cube that was solved on 5 sides, I could get that 6th side, no questions asked. But that was a puzzle, meaning it was something that somebody smarter than me, if not me, could do and solve. A mystery is something maybe no one can ever solve and is unsoluble and insoluble given what we have as human beings. But that wasn't a problem. That wasn't a reason for despair, according to him, and it isn't for me. Because we all, there is a part of life, even if you're religious, that you have to make up meaning, whether that meaning that you make up for yourself is based on, what you want to have happen to you in the afterlife or what legacy you want to leave to your kids. What I find so delicious about life is in practice. So I get to practice not just physics, but experimental physics. I get to build telescopes. I get to go and search in cool and interesting places. I get to interact with smart people from around the world and think for a living and convert food into brain, into writing, into words that someone else maybe 20 years from now will encounter. So for me, that's the mystery aspect of it. There's no proof that any one of us is going to ever get the answer and solve it. For example, it's not for lack of trying. I don't feel very convinced by, kind of the militant atheism. And so I gravitate towards a practicing agnostic. The emphasis is on practice. So for me, I go to temple. For me, I study Aramaic, and I taught myself Hebrew at age 30.
Wow.
I was an altar boy in the Catholic Church. Both my parents were born Jewish. Biologically, I was Jewish from birth, just the same way that, I would say we were Jewish in the same way that Panda Express is like authentic Chinese food. It was just like cultural. Like we'd have, we'd go to synagogue. We used to joke, 2 days a year on Christmas and Easter. But then when my mom, remarried and she got married to an Irish Catholic man, Keating, I fell in love with the Catholic Church. And I became an altar boy, Michael, this Jewish boy at age 13 when I should have been having my bar mitzvah. I never had a bar mitzvah.
Wow.
Instead, I was confirmed, baptized, and I was an altar boy until I learned from Father Monsignor Robert Skelty in Chappaqua, New York. I learned that you had to be celibate. And at age 13, that wasn't something I was super interested in. I don't know why, but
what was the appeal of Catholicism at that time to you?
I thought it was its authenticity, its seriousness, its lack of kind of frivolity. I didn't see people going there with sandals and flip flops, and people laughed. It's a very warm religion. It's very loving and open. There's an emphasis on food and drink. It's like they're forbidden to have a sexual relation, so they kind of malleable, in terms of drinking and smoking cigars or pipes. Anyway, it seemed very interesting to me, and it was part of an elite, and I loved that aspect of Catholicism until I learned about this guy Galileo and how he was mistreated by the Catholic Church. And even by the 1980s, when I was an altar boy, he hadn't been pardoned. He actually has never been formally pardoned. The Vatican did admit that they were wrong. By the way, it wasn't like the Pope was some expert scientist. They have scientists to this day, Michael. The Vatican Observatory is one of the best telescopic observatories on Earth. And there were a lot of things I liked about the Catholic Church's science, in that Lemaitre didn't want to claim evidence for the Big Bang based on his Big Bang model that he ushered in. But that's moving aside from the point. So then I became an atheist. I believed anything that did any harm to a brilliant intellectual like Galileo was not for me. And as I talk about in Losing the Nobel Prize, I thought, well, Christianity is kind of Judaism 2.0. And by modus tollens, if I can refute the conclusion, then the antecedent must be refuted. And therefore, I don't need to study Judaism. And there things stood, until September 11, 2001, when I realized I knew almost nothing about the religion of my birth. And for some reason, this religion played a big role in the evolution of our universe in its current state. So I decided then and there I wanted to learn more about Judaism. I wanted to have a Jewish family. And to learn, and that required I learn Hebrew, which is really hard at age 30.
Well, now what's 9/11 got to do with that? Because of their hatred of Jews and anti-Semitism and anti-Israel?
It was more like, how is Israel? Why is this tiny little country that I previously had no affiliation for? Why was it in the center of all these events going on? The center of the Western world, and what role did it play in America's founding, for example? And what role did it play in the current political dynamic of that war, the second Gulf War that then was becoming? And it just made me feel like an ignoramus, because I knew nothing about Judaism. Like, it's one thing to not be Jewish, and look, I don't know much about Islam or being Mormonism, but I do know about a little more about Catholicism at that point than I did. I knew a lot of the arguments for atheism. I had read a lot of the earlier work, but for me, it comes down to practice. So as an agnostic who practices. Not that I know that, it's unknowable, but if you desist from the quest, like when you're out mountain biking or road biking, I bet sometimes you don't really feel like going out on your bike, Michael, but you do it anyway because it's part of who you are. And it's influenced your entire character. Yeah. So for me, it's had a wonderful influence. Michael, once a week to have a day off where I don't send you an email. I'm not going to be on Twitter. I know you made fun of me because I took so long to get this article done. You're like, get off Twitter. I'm like, I'm off. It's 25 hours a week, but it is refreshing. It is restorative.
Yeah.
And so I said, there's an accumulation of evidence that at least the activity of this life is beneficial to me. And then at worst, in kind of Pascal's wager, what's the worst that can happen? I lead this life true to this religion. Maybe I never come to the firm belief that my rabbi has in the existence of God. But if I desist from trying, I know I'll never believe it. Like Richard always says, there's no such thing as a Christian child. Like he says, he basically has called it like child abuse to say like your child, or Zuckerman has said that like no one's born into a religion, like no one's born believe. But I know something, from experience that actually it's extremely difficult to be born to atheist parents and to become religious. It's just that's just a truth. Like I think it's because of the way that atheism is sort of almost in opposition to an existing paradigm that the practitioners, namely the parents, will really make it almost like a forbidden thing for their kids. Not like literally, but the kids will get this perception that this isn't something for me. And I didn't want my kids to go through that. And so I've left it open and they're learning and I'm learning and it's continuing that as a lifestyle. And who knows what will happen along the way.
Yeah, I think here you're touching on the social and psychological benefits of religion that really have nothing to do with intelligent design theory or quantum physics or any of the stuff we're talking about, which you and I love these conversations. But the average person going to church or synagogue or whatever religious service they go to, they're not going there to hear some arguments for the fine tuning or the first cause, the prime mover, the Kalam cosmological argument. They're going there for the camaraderie and the social aspects, the food, free parking, the kind of moral uplifting stories that much of the biblical stories convey. So, I mean, one of the points I always make about mythic truths versus empirical truths is that, for example, if you're arguing, well, the miracle of the parting of the Red Sea, the actual natural explanation for that is this windstorm or the earthquake or whatever. I think if that's the route you're taking, you're kind of missing the point of the story. The analogy I make is like, well, were there really 4 brothers Karamazov in Russia in 19th century? And it's like, Dostoevsky just made this up. But it's not completely made up. There's a kind of a literary or mythic truth in the story about human nature, about human culture, human history, and the tensions that happen when a kind of a backwards nation like Russia becomes modern and goes through these states. That's it'd be like J.K. Rowling holding a press conference and saying, this whole Harry Potter thing, it's actually true. I didn't make it up. There really is this place, and the 9.5 at the train station, and there's this guy named Voldemort. No, I mean, this would be absurd. People would rightly think she'd lost her mind. But to even talk about that is to miss the point of the story, right? So I often think
right.
Me and my fellow atheists, including things we've published in the magazine, we even published back in the 90s an article that Jesus, this is before Dan Brown, it became popular, that Jesus was never really dead on the cross. He was kind of slipped into a coma, and they gave him this substance that put him in a 3-day coma. And so he's now in this cold tomb that kind of preserved the body for a couple of days. Then he wakes up, and then he and Mary whisk off to, well, the theory was India at the time. I think Dan Brown sent him off to France to have children and so on. But as interesting as those are, I think you've kind of missed the point of the resurrection story. It has nothing to do with, did he really raise from the dead after 3 days and so on. I mean, a lot of Christians absolutely think that has to be empirically true, or else why bother being a Christian? You can just be a Jew, say. Because Jews, they accept that there is going to be a Messiah. He just hasn't come yet, because the story of Jesus is not what the Old Testament predicts that, well, this is what Jews say, that would happen, and that's not who Jesus was. Okay, fine. But again, there's a deeper point to the story about redemption, starting over, the oppression of the Jews by the Romans, and this is a common theme throughout history: is that oppressed peoples tend to have mythic stories about a savior coming, and like the Native American ghost dance that I like to tell. In 1890, the closing of the American West, the U.S. government is oppressing these Native Americans, putting them on reservations and so on, and all of a sudden this thing erupts of in the Dakota Sioux have this ghost dance in which they're all chanting for days on end. About how the buffalo are going to return and the white man's going to leave, and they had these vests that they would wear that they believed would be impervious to a white man's bullets, and on and on. It's very much. I mean, this guy Wovoka, he was very much a Jesus-like Messiah figure, and one of my books I have half a dozen examples of this throughout history where oppressed people. So that's what, to me, the story has much deeper meaning. To which someone like, my fellow atheists would say, well, it's just not true, so it's a bunch of bullshit. We don't have to even think about it. Well, that's too simple, kind of a interpretation of these things.
I think it is. I mean, one of my favorite things, Jefferson had a Bible where he removed all the miracles, and I'm working on my magnum opus will be a Bible with no violations of the laws of physics. And actually, going through it, there aren't that many violations of the laws of physics, and in fact, there are very interesting kind of either they're jokes, Michael, or like kind of insider kind of humor where you have things like the sun is created on the fourth day, so. It obviously can't be that they meant day. Now the question is, what did it really mean? And, and how do we interpret it? But I think they're again, I've said this in talks I've given, looking at the Bible and expecting it to have anything to say about not just Noma or anything like that, but expecting to have anything to say about physics or cosmology or biology and heritability is like looking at a transcript of the 2008 housing crisis kind of autopsy of forensic report, and then say, oh, this is really going to tell me how to raise Labrador retrievers. Like it has nothing. Maybe the word Labrador appears in there once, but I make the point. In one point I said there's about 35 verses in Genesis 1:1 about through chapter 2 or 3 about maybe the Big Bang or the origin of species, whatever. And then there's 35,000 total verses in the Old Testament, which is all I really know. And so that's 0.1%. So it's 1 out of 1,000. So imagine you picked up a book and it's 1,000 pages long, and it says on the cover, it says great, basketball heroes on it. And then like there's 999 pages of the 6 really outstanding Jewish basketball players that have been in NBA history. And then there's one about LeBron James and Michael Jordan. And,
That's funny.
And by the way, one of them was a convert, I think Stoudemire. Anyway, the point being, this is not a book about that. And nor is A Brief History of Time a book about how I want to raise my kids. So, and not that I raise my kids according to the Bible, but there are very interesting things about the Torah that, would be a great, part for 3 someday to talk about, not the science of the Torah. I really find those kinds of things, ridiculous, because it's clear it's not. Again, the sun is created on the 4th day. It doesn't take an apologist to say it obviously doesn't mean what we think it means. But by the way, I have to tell that to my religiously inclined Jewish friends. Will say this is proof, that God can do a miracle, that he created it before the sun, and the sun is it had a very specific purpose. It had to speak to readers 3,000 years ago or whenever it was compiled and written, and it had to speak to readers today. And I always joke, I kill for 1% of God's book sales. And that's serious because, this thing has been relevant a lot longer than A Brief History of Time. A Brief History of Time, I hope it's out of date. I hope my losing the Nobel Prize is not read in 100 years because we know so much more about at least the physics. But, I've often thought, it would be a bad thing if science doesn't get overturned. But how much more so is it good that things like the Torah and the Talmud, which is the second holiest work, they've endured for thousands of years. There's a reason for it. And it's not just mass delusions of crowds. There is wisdom, but that's not to say it comes up as easily as even string theory comes to certain people.
Yeah. Brian, we've been going over an hour and a half. Let me just switch to the lightning round here and ask just a couple of quick questions back to your article for us at Skeptic. Let's see if we can keep these short. What is gravity?
So gravity is the weakest of all the forces. It's in some sense the most mysterious, not only because it refuses to be wedded to the other forces in some kind of theory of everything, should such a thing ever exist, but it's also, it hides what it does in inscrutable places. So gravity is responsible for the large-scale features of the universe, but also the small-scale structure of the Earth. The size of animals is related to the strength of gravity. It's the porous understood, the constant that governs gravitational interactions, irrespective of it not being found a theory of everything, we understand the gravitational constant of Newton's law, capital G. That's the poorest known of all the so-called fundamental constants of nature. It's very hard to measure it on small scales. It's even harder to measure it at the earliest times. And it may be impossible, Michael, to measure it in the situations where it is most interesting and relevant, i.e., at the center of a black hole, what's called a singularity, or perhaps at the beginning of time, which is a moment preceded by no other moments, because those are firewalled off by the expansion of the universe in one case in the Big Bang singularity, and by the so-called event horizon in the context of the black hole singularity. So it may be that singularities don't actually exist, but we'll never know because they're both completely inscrutable.
Okay, let me ask you this question. When I drop this object, it's not being pulled to the Earth by a force. It's what? Pushed by space-time, I think is how Michio described it. And even that intuitively doesn't feel quite right.
I heard that description. It's an interesting description. So what happens is gravity warps the paths of trajectories such that if the object will fall with what we perceive as a curvature, it will take the shortest amount of time, and it will behave as if it's being accelerated. But there's no actual reason that the gravitational force that pulls on the phone when you drop it should be mediated by the same term, this charge that we call mass. There's no reason that mass should be the same as to push an object. The fact that they are exact agreement to 12 decimal places is one of the greatest mysteries of all time, and it's one of the ones that Galileo first perceived when he apocryphally maybe dropped the cannonball and a ball of wood off of the Leaning Tower of Pisa. And we're still learning things about gravity every day. It's the most mysterious of all the forces, and maybe we'll never be able to unify it. There's no law that says we will.
What is time, or space-time if you prefer?
I only can say what time does. So time is intimately connected to change. In fact, that is maybe the most basic law of all of physics, is that change happens, and that change is what clocks can measure. So our bodies are clocks. We have psychological time, but I actually mean the physical degradation of our cells is a type of a clock. There are clocks, celestial events that occur. These are things that clocks can measure. And so time, and it's almost tautological. You can almost not separate the behavior of what we call time from the existence of clocks. And so it's no surprise that actually the first measurements of gravity by people like Galileo came about at a time when the first clocks were kind of coming together. And so for that reason, it's almost impossible to answer the question of time without referring to entropy, and entropy being the tendency of objects within a closed system to get more and more disordered from state description to state description. So if we don't have a great description.
If the cellular disintegration due to entropy is happening at a certain rate as a clock, why does it slow down if I'm at a high speed, if I'm moving at a high speed, compared to somebody who's just stationary?
Yeah, so that occurs because of what is called time dilation, which is a distinction that you think of as puzzling because we don't have experience with things operating at the speed of light. So the notion of if you're sitting on a train and the train pulls away next door to your train, it feels like you're moving, even though it's really the other train moving. That's a consequence of what's called Galilean relativity, which governs the behavior of things in motion at low speeds. Galilean relativity is the extreme limit and the low speed limit of Einstein's special relativity. So the theory of special relativity incorporates two changes that take place. Lengths get smaller, and time gets bigger. So you can close a barn door on an object that's nominally bigger than the separation between the barn door and its wall if this object is moving fast enough relative to the barn, which is stationary. But also things like muons, which have been in the news lately, they will live longer if they're in motion in the cosmos at high velocities, accelerated by a supernova explosion perhaps, than they will on Earth. It's stationary in the laboratory. That's called time dilation. So, but the total interval, so in other words, the sum of time, the effects of time, that time gets lengthened and distances get contracted, they're conserved. In other words, the product of the time times the lengthening of time, the speed of light times the lengthening of time, and then the shortening of length, that you add those up, you get the same amount. And that's deeply related to the conservation of energy. So that phenomenon that you are witnessing is a byproduct of things in high velocity and the conservation of energy, are most closely held of all physical laws.
Okay, what is nothing? In this sense, let's just ask it in the deepest possible way. You have a box, there's nothing in it. So you take the universe, you take all the stars and planets and people and all the atoms and so on, but there's still ideas or logic or math or the laws of nature, whatever those are. So you'd have to take those out, and there can't even be any sentience asking the question, and there can't even be nothing, because nothing is a concept for it not to exist. At some point, I don't even know what I'm talking about.
Right. Well, I think about, so of course that's impossible to answer, but I will say something. You can get all the integers if you start with nothing. I don't know if you've ever gone through this. It's called set theory. There's a wonderful book called Naive Set Theory. It was my late father's favorite book by, I think, Paul Halmosh, with an umlaut in there somewhere that your wife will appreciate. And the way you do it is kind of interesting, because a lot of cultures, think of God as one, and then, kind of everything else is emptiness. So it's really a foundation. The universe is kind of binary, and I'm not going to get woo-woo, I'm not like that. But the universe is kind of binary in that you can get one starting from zero. And the way you do it is this. Michael, how many sets of 0 bananas are there?
One? I don't know.
There's one set, right?
Yeah.
Okay, so, and then what does the set of 0 bananas and conceive of no apples or a universe with nothing in it? How many empty sets are there? There's only one set that contains no elements within
Okay, all right.
And so, therefore, starting with nothing, you get 1.
Okay, all right.
And then starting with 1 and 1, you can get 2 and 4 and 6, and you can get all the integers at least that way, all the rational numbers that way.
Interesting. Yeah. So could you get a universe from nothing? In here, you guys start talking about like quantum foam and the fluctuations and the colliding brains. And again, I get lost pretty quick.
So those are the mysteries, right? So they confuse us because they present as puzzles, but they're probably mysteries.
Yeah. Well, Brian, this is an unbelievably fascinating conversation, because we've dealt with pretty much all the big topics. Did we leave anything out? I think I know. We went way beyond your cover story, which I really appreciate. All right, there's your next book. You have to put all this together and respond to all the intelligent designers and everybody else on the spectrum, as it were.
I know. I'm like an equal opportunity offender.
What is your next big project? What are you working on? What are you working on?
I'm working on the first audiobook translation, recording of Galileo's dialogue.
You told us about that. Yeah.
With Carlo Rovelli. And then I'm working on another book called Think Like a Nobel Prize Winner. I've interviewed 9 Nobel Prize winners and counting on my podcast, Into the Impossible, on YouTube, Dr. Brian Keating. And I'm working on that book. And then I'm also maybe thinking of writing a book about the things we leave behind and what are known as ethical wills, what we want to be remembered by us, not monetarily, et cetera, but in terms of what impact we made on other humans through our wisdom that we've acquired. And those are kind of keeping me busy.
You mean like
teaching,
like the environment?
Yeah, the environment, but more like what wisdom. And I actually asked this of Ann Druyan, widow of Carl Sagan, among many other people on my podcast. I always ask them. I didn't ask you, because I started asking these questions after you came on my pod. You gave me my start in podcasting exactly a year ago. And so it was before I developed these patented questions that I now close each and every episode with. And so when you're on my show next, I'm going to ask you these questions. But one of them is, what would you put in your ethical will? And another one is, how did you go into the impossible, which was Arthur C. Clarke's famous line, the only way of knowing what's possible is to go beyond the limits into the impossible. So, yeah, I'm working on a whole bunch of different projects, but really the Simons Observatory, building this telescope in Chile with 300 of my closest and best and brightest scientists in the world, that's going to keep me busy for the next few years.
Oh, that's your scientific project, is that the Chile? I didn't know you were working on that. Oh, interesting.
That's my main project. Yeah.
What is the hope that it will detect or discover or see?
Yeah, so we don't talk about what we want to discover, else we get diluted by Nobel Prizes and such. But what we are designed to look for are the imprints of early gravitational waves in the infant universe, if they exist. As I talk about in the Skeptic article, those would be perhaps the only harbinger, the only imprimatur of inflation, which comes along concomitantly with the multiverse. And then, but also for clusters of galaxies, for the imprint. Michael, we don't know where magnetism comes to the universe. We don't know how it originated. So we talk about these highfalutin laws of gravity and string theory. We don't know where the earliest magnetic field in the universe came from. We don't know what caused it. And that's one of the things we're designed to detect. And then the last thing is that I'm hoping to look for, not to discover necessarily, but it would be more startling to me, Michael, than discovering inflationary gravitational waves. And that's called Lorentz violation. So Lorentz invariance is the symmetry, is the founding principle of physics. It basically means that I don't care if I do this experiment dropping my phone here in San Diego or in Santa Barbara. It doesn't make a bit of difference. It's independence of location. It's independence of time. You could do it in 1600 or you could do it today. It will behave the same way. What if it doesn't? We actually can't test things over very big distances here on Earth at very long times on Earth, but we can with the cosmos. And so that's what I'm looking for. We're looking for departures from the basic underpinnings of all of modern physics, namely Lorentz invariance. And if we find that, to me, that would be more interesting than discovering the origin of the universe via these gravitational waves.
Yeah, that's fascinating. That's Lyell's principle of uniformitarianism. The past is the key to the present. Maybe it's not. Maybe the speed of light was different in the past, or gravity was different, or whatever.
Right. That reminds me of the last thing I'll say about that Hawking book. There's a scene in there where Hawking had a party in Cambridge I think it was in the maybe the early 2000s or maybe not even that long ago. And then the next day he advertised the party. And he said, come to Cambridge at this time. And he said, and at the party, he said, welcome time travelers. And so, all these things are very, very interesting. Can we discover that the laws that we already know that certain properties of physics depend on whether you're looking at them in a mirror or not, which is very bizarre. In other words, if I look at this Leatherman, multi-tool falling down, it doesn't matter. You're actually seeing the mirror image of it. It doesn't, you can't tell that that's happening. But there's certain phenomena called in the weak interaction that violate this symmetry property called charge parity. I wonder, and my colleagues and I wonder, if the universe has kind of a handedness to it. If it has a preferred direction in space and time, that actually we assume it doesn't, only because we only have such limited distances here on Earth and limited timescales in the human life. But through looking as far back in the universe as we can with these powerful telescopes, we hope to reveal that symmetries have to be broken. That's where interesting things happen. I don't know, do you ever see this thing, Michael, where they show a picture of Brad Pitt, who besides, you and me was considered the handsomest man on Earth by People magazine. Skeptic magazine had a different handsome, but then they take his picture and they just split him down the middle. And they just reflect and he's grotesque. He's horrible. He's disgusting. Even I'm better looking than him. And so symmetries, when they're so that means that broken symmetries are more attractive and appealing. So we're looking for those broken symmetries. So far, we haven't seen it. It means that nature is startlingly resilient and impervious to all of our testing. But that just makes it more of a mystery to hopefully turn into a puzzle.
That's why it would be interesting to come back 1,000 years from now, or be chronically frozen and woken up and then go, oh, that's the explanation for that. That was so obvious. Why didn't we see it in the 21st century? Well, all right, Brian, thank you so much for coming on. I really appreciate it. Great conversation.
Thank you, Michael.
If you liked this video, please let me know what you thought in the comments.